Okay, so today we're looking at increasing and decreasing curves. So our learning intention is to gain the knowledge on using the derivative to explain where the original function is either increasing, it's either decreasing, or it's stationary. To be successful, we need to realize that when the first derivative is greater than 0, the function is increasing. When the first derivative is equal to 0, the function is stationary. And when the first derivative is less than 0, then the function is decreasing. We need to know what the terms monotonic means. So monotonic means if the curve is always monotonic increasing, that means that the f dash of x, or the first derivative, is greater than 0. That's for all of x. So monotonic is when it's always increasing, or it could be always decreasing. So you can have a monotonic decrease, and that's when the first derivative is less than 0. Okay. We want to find the values, here's an example, we want to find the values of x, which the curve y equals x squared minus 3x minus 4, right? And we can factorize that. So y is equal to x minus 4x plus 1, right? We want to find where this curve is decreasing, increasing, or when it's stationary. So because it's a parabola, I've just drawn it out. So yes, we've got x-intercepts at 4 and 1, and the y-intercept at -4. So it looks something like that. So graphically, we kind of know that it's going to be decreasing to this point, and it's going to be increasing at this point. Well, without a graph, what we could do is we can find the first derivative. Okay, so I'll do it here. If y equals x squared minus 3x minus 4, then y dash equals 2x minus 3. So then we ask, So that's the first derivative. Let's say let the first derivative equal to 0. Right? And then just solving it algebraically, we get x equals 3 on 2. What it means is that when x equals 3 on 2, or 1.5, the function is stationary. Yeah. So the function is stationary at 3 on 2. All right, and then obviously to figure out what y would be, we plug it back into the original function. So when x equals 3 on 2, y equals -25 on 4. So this point here is 3 over 2 and -25 on 4. Okay, so when it is decreasing, well, we know it's going to be decreasing over here. So that's going to happen when in the domain of -infinity to 3 on 2, and it's going to be increasing in the domain on 3 on 2 to infinity. Okay, what we could do is we could plug in values. So so what happens when x equals 4? Okay, so the first derivative is positive, so it means it's increasing. And if we had negative, let's say -4, we have the derivative, first derivative as -11, so it's decreasing. Okay, so you can test points on either side of the stationary point. All right, now we have a next question. Prove that y equals x cubed minus 2 is monotonic increasing for all of x. Well, here we've got a cubic, so just quickly have a visual idea of what's happening, we don't have to do this, but just so that you have an understanding of what's going on. So we have -2, so it's a cubic that's translated down 2 units. So it kind of looks something like that, just roughly, right? So you know that it's kind of increasing to this point and it's increasing again. All right, so let's try finding the first derivative. So we get 3x squared. Okay, now as you have an x squared, if you plug in any value for x, that's always going to be a positive value, right? So as x squares will always be greater than 0, then the first derivative will also be greater than 0. Therefore, it's monotonically increasing. For all of x, but x cannot equal 0. Now, the reason why the x can't equal 0 is because this technically is a stationary point. Yeah, so if we had y dash, so let y dash equal to 0, then x would be equal to 0. Yeah, so that's a stationary point. Okay, so find all x values for which the curve f of x equals 0.6x cubed minus 0.63x squared plus 0.5x plus 4 is stationary. Okay, so the first thing we want to do is find the derivative. We multiply that down, so I get 0.18x squared minus 1.26x plus 0.5. All right, so we want to let f dash of x equals to 0. Okay, so this is a quadratic, so I can use the quadratic formula to find my x values. Okay, so that's positive 1.26 minus 4 lots of 0.18, 0.5, all over 2 lots of 0.18. So I get approximately, x is approximately 6.6 or 0.42. Okay, so the x value for which the curve is stationary would be approximately when x equals 6.6 or 0.42 is when the curve is stationary, when the function stationary. And knowing that it's a cubic, that that would sound correct, having 2 kind of stationary points. All right. The last example says, we want to sketch a curve where the first derivative is less than 0 for when x is less than 4. All right, so okay, so when x is less than 4, the first derivative, so on this side, the first derivative is less than 0. So it looks like it's decreasing, so it's going down. When x equals 4, the first derivative is 0. So that means it's a stationary point. And for the first derivative is greater than 0, so it's increasing when x is greater than 4. So really, I can draw a curve that kind of looks like that. Now, it can move anywhere. It can be translated up or down because we don't know where the constant is. Okay, and that's it. Good luck.